Bismillahirrahmanirrahim. Welcome to another episode of network analysis. Before going to discuss important things, let's move towards the recap section. That is very important because today's episode keep relaxed because today's episode is very simple episode, and I can also move this episode towards the 7 or 6 episode before conducting conductance and the inductance parameters, but I want to stay it at here at this position because I wanted because in the start of the series I think we discussed the basic things like charges and charge, defined charge, power, current, these things. These are the basic things. If you are the studying in the electrical engineering, I am very hopeful that you already learned these things. Actually, in the starting things we recapped all the things in a modified form that is helpful and used in the networking, and then we moved toward the first important thing, that is the capacitive parameters, and we defined three basic things, that is the same approach for all the cases, all the circuit, all the systems, that is the physical phenomena, then second field interpretation, and the last but not least circuit interpretation. And finally we discussed the example for the each case of the inductance and the capacitance, and then there is another case and the final case, that is the resistive case. There are the three types of the systems and the networks, that is either it's a resistive, capacitive, or inductive. I think this is the most easier among them, among three other two that are the tougher as compared to the resistive parameters, because these less formulas, less complexities, and the basic things, and most of the basic things that you already you learned in the previous sections. So that is the beauty of this section, I think. That okay. Further important thing, that I can also move this position before the capacitive parameters, but this, after discussion of some complex parameters and the complex activities, complex circuits, and complex formulas about networking, then why not we have a relaxing episode of the episode 14. If I put this episode before the capacitive and inductive parameter, then maybe you found it a little bit boring after this, that continuously capacitance, inductance, and then further networking. Why not there is a break? This is a type of the relax parameters. So this is the motivation basically for today's episode. Okay, get ready. This is the first thing that I wanted to use here. First of all, again, as you can see, this is the format is changed. This format is actually temporary. We are back on the PowerPoint. The main reason is actually because this is a basic episode, and I think then whenever we need basic things that can be explained to PowerPoint and different short headings, that the parameters that can be explained through these PowerPoint presentation, I'm definitely very happier and feeling relaxed when I need to present this. While sometimes the things needs to be explained through the paper, through further explanation is required, and maybe I was not able to use this format to explain. That is the main reason I am writing on my register again and again, and then decide that which one is the easier approach, and then I take the snapshot and use to present over this lecture in this series. So okay, first one is the, for example, there is a conductor. You know that in each conductor there are the there are the free electrons available in conductors. It depends upon the conductors, either they are the more free electrons and the quantity, density. It depends upon material to material. For example, the conductivity or the free electrons of the copper is different with respect to the conductivity and the free electrons in the free electrons with the aluminum or gold, and it is different. So when we are going to apply a voltage signal is in the form of the voltage, or we are applying actually a charge or any type of, you can say, actually free electron that is coming from the one side and wants to enter in this material, then what it needs to do here, this free electron strikes and collides with the next one, because it is not possible that free electron is coming like that and it pass through all the points, and it will not collide with and it may not found any hindrance while going through this, and it usually pass through. It is never possible, because in the free there are the lots of the free electrons, and the free electron that is coming outside, it may found easily in the start, even in the starting portion it may found that another electron. So the collision is definitely it's understood that the collision will happen in a system. So then what next? There are the two types of the collision. That first is the elastic and the second is non-elastic. Let me first describe you about the elastic. This is the elastic collision. Let's suppose a electron or a charge that is moving with the speed of 5, and it collides with the next one, which is actually at initially 0 speed. Its speed is 0. After the collision, the first one, which is coming with a speed of the 5, is now at the position 0 at rest, while the already at rest this one is now taking the speed of the previous one. Totally speed is transferred into the next which was already into the second charge or the second particle. This is called a collision which is elastic, means that all the energy of the first system is perfectly transferred into the second system, means 5 at the speed of the 5 is totally converted into the another system, and now it is going with the speed of the 5. Another case, when the speed of the 5 is going to be collide with this system, and unfortunately some of the energy is lost, and it is taking with the speed of the 5. It is taking now the speed of the 5, but sorry, it is not taking the speed of 4 despite of rather than 5. Then what does it means? It means that energy is wasted, is lost. This is called the non-elastic collision. A perfect elastic collision is defined as a collision in which there is no loss of the energy, and the energy, remember, is a kinetic energy. This is there are two type of the energies also, that one we are discussing about kinetic energy here. Actually the movement here in the conductor is the collision. Basically the electron that is coming from previous side, it's striking with the conductors of with the free electrons that are available in the conductors. Then this the electron that is coming from outside will take the position rest, and the position of this electron that is here, and then this electron going to move. This electron will strike with the next one, and now it is in rest. The next electron will continue with the same velocity, and after striking all the electrons with each other, the next move on. Finally the last electron will receive the motion and the push of the first electron through different pass-throughs, and this will be eliminated from the system, from this conductor. And this is actually the process, means new electrons are entering and finally the same amount of the electrons are leaving. But due to the amount of the resistance, which is called as non-elastic collision here, there are less potential is received at the outside. The velocity and their speed is low, that I was discussing here, that if a basic example, that speed of the 5, if an electron is coming with the speed of the 5, another electron now is speed with this lower speed, so speed is actually reduced. This is the what we called as the non-elastic collision. Now it is taking with the speed of the 4. So this is loss of actually energy, and now we are interested in what is the amount of energy lost. For example, if we are applying, actually energy lost is very low. This is not very high, because we are using in networking very good systems, those systems that have a very high conductivity. that type of systems are usually preferred in networking, so which means that energy is lost but very low. So let's now move toward the second. This is the first section when we just need to take a look at the physical substances and the physical phenomena, and the loss of the energy on a unit charge is interpreted as a drop and a potential difference across the material. This is the first category, and the amount of the energy lost by the electron is related to definitely the physical properties of a particular substance. Now let's move toward the second field interpretation. Before going towards the field interpretation, let's take a look at the German physicist Georg Simon Ohm. You can see the picture of the scientist here found through he actually performed this. Here is the Ohm. You are very much familiar with the Ohm's law. He is the to give the honor, to give the credit, we use the name Ohm for the law. That is the Ohm's law. V is equals to IR. You must be familiar with this law. That is a very basic law. Ohm actually found this relationship that the voltage is directly proportional with the current. If in a conductor, suppose this is a conductor, you are increasing the potential difference or voltage, then there is increase in the current also, and which means that there is a direct relationship between all the material, but there must be a constant. V is directly proportional to R, no doubt, but there is a constant of proportionality is necessary. Sorry, V is directly proportional to I, but there is a constant, that is V is equals to IR. This R is actually here needs to be explained. This R varies from material to material. Every material has its own resistivity, and what we are interested here is actually Georg Ohm, a very scientist. He was a mathematics school teacher and physics school teacher also. Two subjects that are related with each other. Remember, mathematics and physics are related with each other. He started his research as an started his research on an electrochemical cell these days. But unfortunately, due to the low salary, he was not able to manage the equipment and the different activities that he was interested in at that time. He left the school and he changed it. He was now he then joined a new school as a physics teacher. Actually, I don't remember the name of the school, but he received a good salary package, and then he continued his research there. After spending 3 years there, unfortunately the school terminated and closed, and then he joined a good organization, another organization, government organization, and then he worked and published a book there. The name of the book is actually Galvanic Circuit Investigated Mathematically, because he know about his interest is in physics also and mathematics. He related them in a book, and that name of the book is the Galvanic Circuit Investigated through Mathematically, and very important, very very interesting book. And at that time he was not able to get more fame and more appreciation from his work, unfortunately. He presented the main idea of his theory at that time in this book, but his book became very famous later on, get more fame laterally, but actually our discussion is going toward other side. If you wanted to interested more in the more interest in the Georg Ohm, you can search on the Wikipedia. This is a free encyclopedia you can use from anytime, anywhere. Very good website. There is a relationship between current and a substance and potential drop. There is a relationship actually that is given and learned about us from the Ohm's law, from the experimentally. This relationship between the current in a substance and the potential drop means if you are increasing the current, there is still drops also increased. Drops are there. There are the linear drops, either they are linear or non-linear. This is another discussion. I'm not going in this discussion right now. In terms of the field concept, the change in the energy per unit charge, so this is important, energy per unit charge. So let's suppose this is a unit charge. This is actually, this line is summarize all the discussion, but right now this is our unit charge. We are only taking one unit charge right now. not discussing all the unit charges. We have a 1 unit charge here. This is a 1 unit charge single, and if we are applying here energy, this is called, suppose we are applying here energy, and it is in it has a different because this is electric field around it, because this is a charge. So due to this energy, if we have a constant energy, this is a constant field and constant force is on it. For example, we are applying an energy of the 5. You say, let's say we have generally 5 amount of the energy is applied on this substance, and if we change it, change means either we can also increase or decrease the amount of the energy. Let's suppose I increase it towards 10. Then if we increase the energy, change the energy on a unit charge, it will change the force per unit charge. But right now we are only 1 charge, so change on the force too. Its force is changed. Maybe it was first having a different velocity, and it is maybe in motion. If it is in motion, then right now it is in another speed. It is not taking another velocity. So this is the issue first, that it is now changing its force, which in terms of the networking we call as a electric field. Means its electric field is changed. Very simple discussion, if I wanted to say in simple words, that if we have a unit charge, like here, this is unit charge, you are applying electrical energy on it continuously, it has a field around it. Suppose this one. If you are going to change its field, also varies. Like if you are going to change from 5 towards 10, increase, its field increases too in terms of networking. So this is the summarized view of what I wanted to discuss in this point. I think you got it now. Now let's discuss the scientific discussion now. The change in the energy per unit charge, because there are thousands of the charge there in a substance, free electrons and free charges. We can even calibrate. You know, I in the first episode I asked you to remember the amount of the charges in a substances. This is varies according to the depend upon the materials. Anyway, the change in the amount in the energy per unit charge causes a force per unit charge, or simply electric field in the terms of the networking. This effect may be interpreted in terms of the field in the direction, because this is a field interpretation. So in terms of the field in the direction of the current through the conducting surface. If this is a conducting surface, this in having length L, then definitely current, if current is flowing in this direction, then this field is interpreted in the direction of the current through a conducting substance. We will further discuss about this in the form of, with the help of the diagram, because in the next episode I will try to again explain on my register, and I will draw definitely some diagrams there to explain you about this term more, because the next topic is the circuit interpretation and the third point. Right now we are going to wrap up the discussion on this slide, that is the field interpretation only. 2 points are discussed in today's slide. Ohm experiment can be explained in terms of this field and the current per unit cross-sectional area. So we are going to modify the Ohm's formula according to our networking. That is basically again the same thing, but according to our desire and our requirement, we changed it. This formula J is equals to sigma E. Actually that tells us about that current density as charge density. So this is the current density, J is equals to, so why not we going to select the laser pointer here, J is equals to sigma E. Here if you wanted, I want to discuss the standard units for it. Current density is measured in amperes per square meter, is equals to E, that is the definitely electric field around the conducting substance. For example, if we have a long length L, the field around it, around the cross-sectional area, field definitely covers an area, so we will discuss the field definitely. And then it is measured in volts per meter. E, field, electric field is measured in volts per meter. And finally the term here, conductivity of the substance is denoted by permittivity. Sorry, denoted by sigma. Actually, this formula gives us the value constant for each particular material. Means if you change the material, the sigma also change, which is the conductivity of the material. Conductivity of the materials is approximately constant for all the isotropic substances, means for those substances which gives the same value when measured in different directions. Like copper, if you measure the value of the copper conductivity, it will remain the same at the shop when you are going to buy it, and when you take it and apply your copper wire into your home wiring, it will still showing the same conductivity that was first when you buying. So which means that those materials are called isotropic substances, that type of material which are not going to vary according to the with the passage of the time, or varies according to the directional, varying according to the conditions. No doubt the value varies, but very very less, so we are going to ignore it right now. So we said that this formula gives us a constant value for all the substances we want to measure for all the particular materials. So this is the end of the discussion from today's episode. We will continue the further discussion, but from the next episode 15. So stay tuned, watch, learn, grow. This is Izziran. I'm signing off. Thank you. Allah Hafiz.